Hello, Algebra 1. Today we are going over number 98. It is the final event of the big tricycle race. We're going to see who wins it all. So here we are given 4 out of the 6 competitors' information and what it looked like when they were racing. So the first question we need to answer, do all the riders have the same start point, or do they start at the same point? So I'm going to go through in my green, circle anything that mentions their start point. So I see this person has a head start, but we don't know who Elizabeth is yet. We don't know who Leslie is. But rider C got a 4-meter head start. Rider D got a 1-meter head start. So my answer is no. Now what else do we know about the race? So not about the people, but about the race. Well, I know for sure that it is 25 meters long. That is very important information. And our last question, what else would we like to know? Well, we definitely want to know about Elizabeth and Leslie, because we don't know anything about them. I'm going to write Liz information. All right. Oh, and look at that. There's Elizabeth's information. So she is 11 meters into the race after 4 seconds. So that's one piece of information. But is only 13 meters after 12 seconds. She got a flat tire. Oh, boo, Elizabeth. Sorry, girl. So how fast is she going? Well, between these 2 points, so from 11 to 13, she gained 2 meters. And from 12 to 4 seconds, she gained 8 seconds. And if we think about how we represent a rate, is always going to be meters per second, or miles per hour, or kilometers per day. So her speed is going to be 2 meters every 8 seconds, but I can simplify that, which is going to help us once we graph. So that simplifies to 1 over 4. And I'll show you how I got that. All I did was divide the top by 2 and the bottom by 2. So where did she start the race? We don't know that piece of information yet. So I'm going to leave it as a question mark so that I know to come back to it. Write an equation for the line representing her race. Well, we can definitely go ahead and write the beginning of that equation since we have her slope, which is her speed. So we've got 1 over 4. We always have an x, but we don't know where she has started yet. So let's go ahead and hop down to our graph. And I'm going to graph the 2 pieces of information that we know. So 11 meters at 4 seconds. 11 and 4. And our other piece of information is 13 meters at 12 seconds. So 13 at 12 seconds. So we need to know where she is crossing the y-axis. So we know that we have a slope triangle that is simplified to 1 over 4, 2, 3, 4, and then do that again, up 1 over 1, 2, 3, 4. So let's work backwards. So first we went up and right, but since we're working backwards, first I'm going to go left, 1, 2, 3, 4, and then I'll go down 1. So notice how our slope triangles, even though I haven't completed the triangle yet, I've drawn the sides. Those are all rise of 1 and run of 4. And now I can go ahead and draw a line. I'm going to make it as long as I can since I know that the race is 25 meters long. And it looks like Elizabeth's not going to finish for quite a while. But we can go back and answer this guy. So I'm going to erase my question mark. And I know that she starts the race, according to our graph, at 10 meters. Which means I can also add that 10 to our equation. Now there's one thing I forgot on my graph. If you noticed it, I'm very proud of you. I forgot to label my axes, which you should always, always, always do whenever you are graphing something. So we know that this guy is our meters and our x-axis is our seconds. All right, next we're going to talk about Leslie, who was our other unknown person. She rides 2 meters per second and starts 2 seconds after the start of the race. So in the past, all of our starts have been in terms of meters, but it looks like Leslie is 2 seconds after the start of the race, so she's actually running a little bit late. So I've got my graph here with Elizabeth, and since I'm adding to it, I'm going to go ahead and label this line as E for Elizabeth. So it said that Leslie gets a 2-second late start, and so seconds is on our x-axis. And then it said that she travels 2 meters per second. So from here, I'm going to go up 2 every 1 second. 2 meters, 1 second. 2 meters, 1 second. And as long as I've got a couple points there, that gives me a really good guide for where to put my line. All right, and again, I'm going to label this line with an L for Leslie. And let's scroll back up, make sure we answered the question, we got the graph. Now we're going to write the equation. So we've got our y equals always. We know that she started 2 seconds later, but we're not going to put a 2 there because the 2 is in terms of our x-axis. So we need to figure out where the y-axis, where Leslie would have started. So we know that our slope triangle is up 2 to the right 1. So now we're going to go the opposite, to the left 1, down 2. I'm still not on the x-axis yet, so I'm going to go left 1 and down 2. So my graph got cut off here a little bit, but hopefully yours is better than mine. So it looks like she is at, here's 0, at -1, -2, -3. So this is a y-intercept of -4. So I've got our -4. We always have our x value, and then 2 meters per second. So you can write this as 2 over 1, or 2 divided by 1 is just a 2, so you could write it that way as well. If your teacher likes one over the other, your teacher will be sure to tell you. If you are in Miss Layer's class, in my class, I am happy with either way. All right, our last question before you do some stuff on your own. What do you notice about the graph of Leslie and Elizabeth's line? Any observations that you have? So let's go back and take a second to look at our graph. I'm going to write down a couple things that I saw. This is not an extensive list. You may have observed something that I did not write down on this list. So I'm going to write that Leslie overtakes, which means she is now in front of Elizabeth. At 8 seconds, which is also the 12-meter mark. I'm also going to write that Leslie is faster. I'm going to write Elizabeth. I'm just going to write the E. Elizabeth got a head start. But between these two, it looks like Leslie won. And now, once you've written down all your observations, you can watch this short video before moving on to the solo or team problems.